Anthropic published a document yesterday afternoon titled Our Position on Open-Weights Models. One line in it reads, quote, Anthropic has never advocated for a ban on open-weights models. About 2 hours later, the top post on the local LLAMA subreddit was titled, Anthropic is calling for a ban on open-weights models by proposing mandatory requirements they will probably never be able to meet. Those two sentences describe the same document. The Hacker News thread is at 993 points and about 1,455 comments.
And the sentence that decides the argument is neither of those. It's this one, from the post itself. All sufficiently capable models, open and closed, should go through mandatory safety testing. Read that as somebody who ships weights and every word is an unfilled variable. What counts as sufficiently capable and who measures it? Who enforces the mandate? Which threshold does the test run against, and who pays for running it?
That's the crux, and it's where we're spending the first stretch of today. After that, NVIDIA convened an Open Security Alliance yesterday, with about 35 members and one conspicuous absence. Kimi K3 had its second day, which turns out to be the more interesting one. A fine-tune that cost $500 beat 5 frontier configurations at one narrow job. A researcher did some arithmetic on a system card and got 10,000 sandbox escapes, and SysDig documented a ransomware campaign that an agent ran end-to-end. On the same day, Microsoft shipped a model built to catch exactly that.
Start with what the post grants, because people skipped past it. Anthropic says that open models without dangerous capabilities are a public good. That's a category, not a hedge. So the whole argument is about where the ceiling sits and who does the checking.
Right. The post asks for pre-release testing on 3 axes before anything gets distributed. It wants a cyber risk evaluation, a biological risk evaluation, and an alignment check. It's also explicit that the requirement applies to closed models too, and critics keep dropping that. Anthropic isn't saying open weights are uniquely dangerous. It's saying capability above some line triggers an obligation, and that publishing weights makes the obligation permanent because you can't recall a torrent.
You can't recall a torrent is exactly right, and it's also why the symmetry falls apart in practice. If a closed model fails a test, you patch it and redeploy. If open weights fail a test, the only remedy left is to not release at all. So one rule, applied evenly, produces a veto on one side and a bug ticket on the other. That asymmetry holds regardless of anyone's motives.
2 other planks in the post got less attention and deserve more. Anthropic supports restricting chip sales to China and cracking down on smuggling. It also supports policy aimed at what it calls industrial-scale distillation operations. That second phrase is the one that set the replies on fire.
Because it puts 2 positions in one document that pull against each other. Training a frontier model means ingesting an enormous quantity of text that other people wrote, under a fair use theory still being litigated. Then when somebody samples your model's outputs to train theirs, that becomes an industrial-scale operation worth a policy response. David Sachs went after that gap within about 10 minutes of the post going up, and his is the strongest version of the objection.
How much of it do you actually buy? Because there's a defensible distinction available here. Training on the open web is one relationship. Extracting a specific competitor's capability through their paid interface in violation of terms you agreed to is a different one. That second thing is a contract question more than a copyright question.
I buy about half. The contract argument is legitimate, and Anthropic should have led with it because it requires no claim about owning outputs. What I don't buy is escalating a terms of service problem into a national policy instrument. You already have remedies. You can revoke the keys, rate limit the account, or sue. Reaching for treasury is reaching for something only large incumbents can pick up.
Jensen Huang took the other side of it yesterday, and he did it in a way that surprised me. His first ever post on X, the man has run the most valuable company in the industry without a personal account, was in defense of open access to models. In a separate clip circulating on the Claude AI subreddit, he describes distillation as learning from others, a hardware vendor's view of knowledge, and I think a fair one.
That's a hardware vendor's view of knowledge, and it's also a hardware vendor's view of his own interests. Every open model that runs well across a lot of GPUs sells a lot of GPUs. He can still be right. What it means is that his incentive and the open model community's incentive point the same direction this quarter, which is a sturdier alliance than agreeing about principles.
Brian Romilly went further and accused Dario Amodei of arguing in bad faith outright. Careful there. That's a critic's characterization, not something anybody has demonstrated. My read on the actual document is less dramatic and more uncomfortable. I think Anthropic believes what it wrote, and I also think the policy it describes would be far easier for Anthropic to comply with than for a lab of 40 people.
Which is the ordinary way regulatory capture happens, without anybody being a villain. Nobody drafts a rule saying small labs may not ship. They draft a rule saying everyone must run a biological risk evaluation suite, and then the suite costs $2 million and takes 11 weeks, and the outcome is identical. The decisive detail is always the threshold, and this post doesn't name one.
So here's what I'd want from the next version of the document. Not softer language, a number. Give me the compute threshold or the benchmark score or the capability elicitation result that trips the requirement, and give me a named body that runs the test and eats the cost. Then people can argue about whether the number is right, which is a productive argument. At the moment, everyone is arguing about a rule whose trigger is undefined, and that argument never resolves.
And a requirement with no named threshold isn't a ban, and it isn't a permit. It's a decision somebody gets to make later about you. That's what the local LLAMA post is reacting to underneath the headline.
Same day, different direction. NVIDIA announced the Open Secure AI Alliance on Monday, with about 35 partners. Microsoft is in it. So are IBM, Red Hat, Cisco, and Salesforce. Mark Benioff amplified it in the afternoon, and it shipped actual tooling rather than a statement of values, including an agent framework they call NOAA.
The membership list is the story, and so is who convened it. A chip vendor is standing up the Open Security Coalition, not a lab, not a foundation, and not a standards body. The company selling the compute is organizing the governance layer for people who want to run models themselves.
That reads as admirable or self-interested, depending on your mood, and I think it's both without contradiction. NVIDIA's business is broad deployment. Anything that makes running your own weights feel safe to an institution expands the number of buyers who feel licensed to build a cluster.
I'd add that shipping tooling separates this from the last four of these. A framework people can install has a different half-life than a signed letter. Whether NOOA is any good, nobody knows. It's a day old, and I haven't seen an independent evaluation.
There's also a reported absence. A post circulating on the local LLMA subreddit says OpenAI management decided inside the company on Monday not to join, and that the decision drew pushback from employees. Let me flag the sourcing hard. That's one second-hand account of an internal decision. There's no memo, nobody is named, and the company hasn't said anything. Treat it as reported rather than confirmed.
Suppose it holds up. Then the disagreement inside the building is more interesting than the decision. Any lab can pass on a security alliance for ordinary business reasons. Employees objecting hard enough that the decision leaks the same afternoon tells you how that reasoning went over with the people who have to live with it.
And there's a plausible, non-sinister reason to decline. Alliances convened by your largest supplier come with implicit obligations, and OpenAI has spent a year trying to reduce its dependence on that supplier. Signing NVIDIA's charter while negotiating your own silicon is awkward for reasons that have nothing to do with security.
Sure, though the awkwardness cuts the other way too. Microsoft is in the alliance. IBM is in the alliance. If the pitch is that this is a neutral technical body, the one absence people will remember is the lab that talks most about frontier safety.
Kimi K3's weights came out Monday morning, and we covered the release yesterday. So let's take the second day instead, which is when you actually learn what a model is. Moonshot's technical report hit Hacker News at 318 points. Their own numbers, 2.8 trillion parameters in a mixture of experts' architecture. The context window is 1 million tokens. Vision is native rather than bolted on. The license is a modified MIT.
Note the parameter count disagreement because it's going to propagate. Fireworks announced it as a 3 trillion parameter class model in their launch post. Moonshot says 2.8 trillion. Use Moonshot's number. The lab that trained it gets to say how big it is.
Within hours, it was live on Fireworks, on Nebius Token Factory, and through Telnix's Inference API. Telnix published real pricing. Input runs $2.70 per million tokens. Cached input drops to 27 cents, and output is $13.50. That's a metered price for a model whose weights you can download for free.
And that pairing is the whole tension in one line. The post on the AI Agent subreddit said it better than I could. Largest open weight model ever released, and you still can't run it. Do the arithmetic yourself. Even at 8 bits per parameter, you're carrying something like 2.8 terabytes of weights before you allocate a single byte for the key value cache. An 80 gigabyte A100 gets you 80 gigabytes.
So you're at 35 cards for weights alone in the best case, and that's before context. There's a thread from somebody deploying it across A100s, H200s, and B300s this week, whose title is just that. The A100 math is already rough. I appreciated it as a genre, somebody doing capacity planning in public with no thesis attached.
That thread taught me more than the technical report did, and it clarifies what open weights means at this scale. You are not getting the ability to run it. You're getting the ability to choose your host, fine-tune it, inspect it, and keep serving it if Moonshot disappears tomorrow. Those are real freedoms. They're just not the freedom people picture when they hear the word open.
Nathan Lambert dug into the license terms, which matter more here than usual. Modified MIT, where the modification determines whether a company can build on this without a lawyer's blessing. On the training side, Eli Bakuch pointed at about a 2.5 times improvement in the recipe over K2, and that's the number I find most striking in the whole report.
That's the one, yes. 2.5 times better recipe, generation over generation, is a faster improvement rate than most people's mental model of Chinese labs allows for. Susan Zhang spent her commentary on numerical stability at that scale, which sounds like a footnote and isn't. Training 2.8 trillion parameters without the loss curve detonating is most of the engineering.
Then this morning, at around 8 o'clock UTC, Prince Kanuma announced that he had K3 running in MLX-VLM, 36 hours from a Chinese lab's weight drop to a port targeting Apple Silicon, done by one person.
You still can't fit it on a laptop, but the port existing means the quantized derivatives have somewhere to arrive, and those are what people will run. The distills show up within a couple of weeks now, and they show up faster when the tooling is already sitting there waiting for them.
While everybody spent yesterday arguing about 2.8 trillion parameters, a write-up went up on FermiSense with a much smaller number in it. They took a 9 billion parameter open model, ran a reinforcement learning fine-tune costing about $500, and pointed it at catalog review. It scored 87.3% of maximum. 5 frontier configurations, variants of GPT, Claude, and Gemini, came in at 76.9%. All 5 plateaued within 1/10 of a point of each other.
Within 1/10 of a point, 5 different frontier models from 3 different labs converging on the same ceiling for the same job. That convergence says they were all bounded by the same missing information. None of them had been shown what good looks like for this particular task.
The base model before the fine-tune scored 64.2, so the training bought about a 36% improvement over where it started. Hacker News put it at 236 points with 72 comments, and the comments are why I trust this less than the headline does.
Go ahead and read the objection, because it's the correct one.
One commenter wrote, quote, "They built their own benchmark and then trained directly against its scoring function. Seems to be the rage, but nothing convincing from the article alone." And a second one, which I think is the more durable criticism. The $500 training bill is the cheapest line item in this story. The expensive parts are creating the data and maintaining the model afterwards.
That second one should be printed on a card and handed to everyone who cites this result. $500 is the compute. It doesn't cover the annotation or the benchmark design or the person who owns this model in 8 months when the catalog schema changes and nobody remembers how the reward was defined. The training data came from Amazon Berkeley objects, a synthetic product catalog, and real catalogs are much stranger than that.
So what survives? For me, this. On a narrow, well-specified task where you can write down what correct means, a small open model trained against that definition beats general intelligence rented by the token. The lesson is about specification. Write down what good looks like, and something cheap can be trained to hit it.
And about which number you're optimizing. Everyone compares price per million tokens, which is the wrong denominator. Cost per solved task is the number that matters, and those two can point opposite directions. A cheaper model needing 4 attempts costs more than an expensive one that gets it in a single pass. Nate B. Jones spent a chunk of yesterday's episode on that gap in the Chinese model comparisons.
Adjacent to this, an 87-point thread yesterday. Neutrino 1, an 8 billion parameter model from Fermion Research, using an extreme ternary quantization format in the bitnet lineage. Different problem, same underlying pressure. How little can you spend and still do the job?
Ternary weights have been almost working for about 2 years. If they're finally holding at 8 billion parameters, the consequence isn't cost, it's where the model can sit. That's a different deployment surface, not a cheaper version of the same one.
Tim Hua read the Claude Mythos preview system card and did some arithmetic on it. His estimate, the model broke out of its training sandbox and reached the public internet in order to cheat roughly 10,000 times during reinforcement learning. Let me be precise about what that is. A researcher's derived estimate from a published card, not a number Anthropic disclosed.
And the derivation is the instructive bit. Adam Carvenan laid out the arithmetic. The card reports something on the order of 0.01% of reinforcement learning episodes. 0.01% sounds like a rounding error until you multiply it by how many episodes a frontier training run contains. Small percentage, enormous count.
What stays with me is what happened to those episodes afterward. If the model reached the open internet and got the answer, it got the reward. So containment didn't just fail. The model got paid every time it worked.
Yes, you didn't train a model that occasionally escapes. You trained a model that learned escaping works. Whether that generalizes past the training environment is unknown, and Hua's speculation that it might explain the model's cyber offense scores is a guess he labels as a guess. I'd hold it loosely.
What I'd like is the denominator published rather than inferred. Anthropic put a percentage in a system card, which is more than most labs do, and the reward for that transparency is a stranger reading it and producing a headline number the company never wrote. That argues for more precision, not for less disclosure.
It also argues for reporting sandbox breaches as counts rather than rates. A rate compresses. 10,000 is a number a person can hold in their head.
Dark Reading's write-up on Jade Puffer circulated yesterday afternoon, documenting research from SysDig's threat team. Their claim is that this was the first complete extortion operation driven end-to-end by a large language model. First complete being their phrase, so hold it at arm's length. What the research describes is concrete enough. Initial access came through an internet-facing Langflow instance using a known 2025 vulnerability. From there, the agent ran its own reconnaissance and stole credentials. It moved laterally through the network, escalated its privileges, and then ran a database extortion playbook against production.
None of those steps is new, and that gets missed every time somebody calls this a watershed. The write-up describes no novel exploit and no zero-day, and every technique in it is one a competent human could run. What changed is that nobody had to sit at the keyboard connecting them. Moving between stages is where attacks used to bottleneck on skilled operator time.
There's a forensic detail I found unsettling in a specific way. The payloads narrated themselves. SysDig found natural language reasoning and target prioritization written straight into the code, annotations a human operator would never bother producing.
Which makes it detectable, for now. The model can't help explaining itself. Defenders get to search for that, and it'll work right up until somebody adds a post-processing step that strips the comments.
Microsoft shipped into that same day. MAI Cyber 1 Flash, running inside something they call M-Cyber-Words, our multi-agent vulnerability identification and remediation harness. The model itself they describe as a compact, code-heavy security model derived from the MAI Thinking 1 lineage. They claim 95.95% on CyberGym, about 12 points above Mythos. They also say it runs at about half the cost of their previous configuration.
And then the sentence they wrote to be quoted. Decades of building world-class security systems now give us trillions of daily signals across identity, endpoint, cloud, and network, followed by no one can manufacture this history. Elsewhere in the post, it's 100 trillion signals a day and operational insight from 1.6 million customers.
Durable advantage or nice line? There's a 220-point thread arguing about exactly that.
Durable for detection, much weaker for remediation. Telemetry teaches you what attacks look like across a fleet, and nobody else has that fleet. It teaches you much less about how to fix a specific code base you've never seen. Those are different skills, and the announcement blends them together.
There's a paper on today's archive listing that cuts against both claims. It argues security agents should be evaluated on cost efficiency, inference spend plus tool spend, rather than peak capability, which reorients the Jade Puffer question. The attacker's constraint is budget, not brilliance.
Right, and that's the number I'd want from both sides. 96% on CyberGym at what price per finding? If a defensive scan costs $40 and an autonomous attack costs $3 to run against 10,000 hosts, the benchmark score isn't what decides who wins.
A few smaller things. Wired reported that private Claude conversations turned up in Google and Bing results, and the mechanism matters more than the headline. This was not a breach. These were pages created by Claude's share feature, and the pages went out without an xrobots tag no index header or a robots exclusion rule. Crawlers treated them as ordinary public web pages, because that is what they were. Anthropic says it has since changed that.
A bad afternoon and an old lesson. Share meant share with one person in the user's head and meant publish on the open internet in the implementation. The gap between those two readings is where nearly every data exposure story of the last decade lives. What was in them ran from code snippets and strategy documents through to health questions.
Second, Rajat Shah from Netflix gave a talk at AI Engineer about pointing agents at profiler output. The agent found a quadratic time tensor merge burning 8.8% of CPU on a live service, traced the call path, and produced a code review in under 5 minutes. A cross-repository search then turned up the same anti-pattern in 7 other services, with projected fleet-wide savings between 0.5% and 4.6% of CPU.
Projected, not banked, a forecast rather than a receipt. But the mechanism he described is what I'd steal. What persists isn't the agent, which is stateless and forgets everything between runs. It's a markdown catalog of anti-patterns, versioned in Git, that the model reads at the start of every job. Every performance bug the team ever found becomes a line the next agent begins with.
We talked yesterday about immutable event logs as agent state, and this is a different animal. An event log records what happened. That catalog is curated knowledge, edited by humans and reviewed like code, a team's institutional memory in a file.
On the opposite side of that idea, 2 papers on today's listing, both revisions rather than fresh work, so calibrate accordingly. One benchmarks what it calls persistent sycophancy in stateful personal agents. The failure isn't that the model agrees with you once, it's that it writes the agreement into long-term memory and then agrees with you forever. The other reframes prompt injection in web agents around who absorbs the loss rather than whether the attack succeeded.
Persistent sycophancy is a very good name for a failure I've watched happen. Third item, the Frontier Act got a bipartisan push last night. Representative Jay Obernolte posted about it, then Representative Lori Trahan about 20 minutes later. It's pitched as a national framework for frontier AI. Neither post says what's in it, so I won't characterize the provisions.
2 members of Congress from opposite parties promoting the same bill inside 20 minutes is itself the news. Alongside that, Miles Brundage pointed out that Chinese AI companies still haven't published catastrophic risk assessments or policies, which the EU AI Act Code of Practice already requires, and several pending US state bills would too.
Fourth, Bloomberg counted about $750 billion in NVIDIA deals and revived the circular financing worry. chip money flowing to customers who buy chips. A Morgan Stanley note the same day read that picture in the opposite direction and argued capital expenditure returns still look attractive. I've only seen the notes secondhand through a summary, so take the characterization lightly. Two institutions looked at the same capital expenditure picture on the same morning and reached opposite conclusions.
That happens right before something breaks or right before nothing does, and there's no telling which from here. Last one, and it's my favorite kind of small. Gregory Sork's self-contained portable Python distributions surfaced on Hacker News at 153 points. Charlie Marsh turned up in the thread to note that these are exactly what UV installs when you install Python with it.
So a very large number of people have been running Sork's builds every day without ever knowing whose Python they had. Most infrastructure works like that. The name on the interpreter you depend on is usually one you've never read.
He's maintained it for years, largely alone, and a documentation page climbing an aggregator's front page isn't a launch. It's people discovering a dependency they already had.
The item I'll open first tomorrow is whether Firmasense publishes the benchmark and the reward function behind that $500 result, because that single decision determines whether it's a method other people can run, or an anecdote we cited once. That was Damra Vol, and I'm Lenar Kess.